Hi, Peter.
Hey, what's up?
Not much. We're just kind of getting set up. We'll probably be ready to start, and my guess is we're still missing one person. So probably about 5 minutes or so. So I'm just going to leave you on, and then I'll pick you up once we're ready for you.
Sounds good.
Cool. I'm flying out to San Francisco tonight.
No way.
Yeah, it's gonna be fun. Maybe I'll see Evan's out there, right?
Yeah, Evan and Ted.
They should come to my top secret conference that I'm going to.
Oh, is that the one?
Yeah.
Holy shit.
It's gonna be great.
Dude, that's crazy.
Yeah.
What? Can I tell them about it?
Okay, you can tell them about it, yeah.
Okay.
Yeah.
Cool.
Totally.
Dude, that's crazy.
It should be a lot of fun. I had Danielle prepare some anecdotes and slides.
Is she coming?
No, she's not coming.
Okay.
I'm gonna try to get her to Skype in though. That'd be fun.
That's gonna be a ride.
It should be pretty strange. I should send you. Have you seen the schedule?
No, I haven't seen it.
I'll send you the schedule for it. There's all kinds of just weird, random stuff being presented. It should be pretty
Dude,
fun.
send it to me.
Yeah.
That's this weekend?
That's tonight.
Oh, that's tonight.
Tonight, I'm flying up there, and then the opening thing is tonight, and then it goes throughout the weekend.
Oh, wow.
Yeah.
That's crazy.
That should be pretty cool.
That's gonna be awesome.
Awesome! Can you see one thing we got going on already?
I see a car
Uh-huh.
with a box on it.
Uh-huh.
Moving.
It's moving. Oh, this is rad.
Wow.
There's crickets in that box. And
Really?
they're driving it around.
Oh, that's awesome.
That's pretty sweet. So who wants to be we're just waiting on Anna, right?
Oh
Oh no!
Aha, Fluon doesn't work for things that can jump over the Fluon surface.
Just bug, man. Dude, I'm not scared of that.
Do you guys know about
I'm scared of touching
trapjaw ants? Trapjaw ants? So, correct me if I'm wrong here, but there's these ants that have these huge mandibles that go out like this, and they open them up like kind of like a bear trap. So they like pry them open, and then they have them basically on like a little switch, and they can just release it, and they snap. And they're like one of the fastest animal movements around. But they didn't know there was a secret ability of them that they didn't really know about until they brought it to the lab, and they noticed that some of the ants started just disappearing. And that was, they can, to escape things, snap against the ground, and it launches them away. And people would just have like these buckets of ants, and they were just, all the ants were disappearing, and they were like, where are they going? And they filmed it with a slow motion camera, and they just see these ants flying away from snapping against it. It's pretty cool.
That's interesting.
This is rad. Alright, who's going to be the first one to present? Whoever makes it up here first gets to present. What's up, man?
The only thing that survived my project is this. The project caught on fire last night when I plugged it into the wall.
Yeah.
Like a similar trend. Mine also caught on fire. My computer is completely fried now. I'm not really sure. It was part of mine, but I partitioned it off and fixed part of it. But that's so the speaker survived.
Huh. Is this a speaker or a microphone?
Microphone, sorry. So yeah, I mean, really? Yeah. My sister accidentally stepped on it, so I was resoldering everything.
Ooh.
And then when I resoldered them, I accidentally switched to the wire, so I plugged it into the wall. I was like, really? Oh no! I was like,
man.
oh my god! So, it's completely ruined.
Sorry to hear about that.
It's okay.
You got documentation of
I did.
before?
I sent it to you.
Awesome.
And I have honestly, I think my relay still works after catching it.
No, my relay is, well, mine could work, I'm just not touching it.
Yeah, I kind of don't want to try it either. I was trying to be an electrical engineer to get over it. I was like, oh yeah, my brother was an electrical engineer and got really mad at me for using a relay. So if we do this class 10, just advise people not to use relay. Yeah, we're gonna go there because lots of my apartments like so. But do you want this? This is yours.
No, it's not mine. It's yours.
Also yours. But I can like demonstrate with Larry.
Andy, do you want me to bring you my project or can I leave it here for now?
We're gonna walk over to your project when we check it
Well,
out.
I can show you that now and then I can do my PowerPoint.
We're gonna have everyone do their presentation
And
then show your project. Okay? So, and because we're already running a little behind, let's get the ball rolling. So everybody hop up here in this first little zone. We'll show the project after you do your presentation. And come up here, I'm going to introduce you to our esteemed guest of honor today.
Do I plug it in with this cord?
Yeah. Yeah, just pull that out and then plug it into your lightning or Thunderbolt port.
Do you mind if I put this up?
My dad
Yeah. And then
well,
plug
like,
it in. Laptop.
if it's the motherboard,
There you go.
sorry, but it's probably yeah, mine
What kind of computer was it?
is the HP.
Whatever you think.
I mean, he's talking to it before, believe it or not.
Huh.
So it's a warrior. But I'm hoping
it didn't kill it.
Mary, I think we're looking for I melted it across it. I think it'll be okay.
Cool. Okay, you gonna present first?
Yeah.
All right, first, hop over here. I want to introduce you guys to our guest. So welcome. We're gonna have our first big presentation day. Peter Martin here is our awesome guest of honor, and he is going to introduce himself to all of you. So let's give him attention and a round of applause.
The computer.
Okay, ready? Go, Peter.
It's frozen.
Oh, he's frozen.
Yeah.
Horrible timing. Okay. You got me?
Yeah, we got you.
Hey guys.
Hey.
Hello. I've never done this before. This is kind of cool. I'm Peter Martin. I am a PhD student at Arizona State University, and that's where I'm Skyping from right now. And I'm getting my PhD in animal behavior. I study ants, and particularly interested in collective behavior and how all of these little agents work together to create these emergent properties at the colony level. And the question that I'm really interested in is, can an entire collective of individuals that we can call a superorganism, basically, because it all functions as one organism, can it maintain a collective personality that's sort of functions as its own unit? So this colony over here might be super aggressive and super bold and likes to explore, whereas this colony over here is timid, shy, and reserved, calculated for its resources and stuff like that. And so can those personalities be maintained over time? You know, are there traits correlated with one another and stuff?
And
stuff
so
like that.
people have studied personalities in other types of animals before, right?
Exactly. So the last 10 years, there's been this real surge in interest in non-human animal personalities. Basically, that they've shown that individuals are consistent in their behavioral tendencies, which is pretty intuitive, right? I mean, even if we've all had pets before, and they're all different, you know, they're especially dogs and cats. And that doesn't end just with our pets. It extends to all types of things like birds, spiders, fish, even starfish have been shown to have these consistent behavioral preferences that people are calling personalities. But it's just being explored at the collective level, the level of the superorganism, basically. So that's what I'm looking into.
Cool.
And so most of my research is based out of Panama in the jungle, which I'm sure Andy's told you a little bit about his work down there. Yeah, so we've collaborated down there quite a bit. And so there's all these things that I need to measure down there, and so and interact with the tree and all this stuff. So Andy and I, we work together on a lot of little projects, including a lot of these feedback loops with the Azteca ants and other animals around Panama, stuff that you guys will be presenting today, I'm hoping. So yeah, that's pretty much how Andy and I, we got started through a collaboration through our labs, basically working on this tracking software. Not totally unrelated, but unrelated to how we're interacting now. Sort of more as like collaborating directly on both of our projects. I'm sort of collaborating on his end on, he's studying how, he's basically studying animal behaviorists and how they interact with their study organisms and how their study organisms interact with them, this feedback loop, right? This, it's a constant theme. And then I'm studying these ants, and so he's helping me study the ants and build tools that will allow me to measure certain things that are harder to access. So that's basically my story, his story.
Cool. Okay. Well, let's start up with our first presentation of the day. Awesome. Okay. Can you see that all right?
I can see that, yeah. It's a little light, but I can see it.
I'm going to get you even closer. How's that? Better?
Yeah, that's nice.
Okay, cool.
Okay, stupid Patrick. That was our project.
That was your project. Oh, you can't see the speaker. Yeah, maybe we're gonna.
Oh no, now it's 8 people.
Now there's 8 people looking at you.
Okay, everything will be alright.
Yeah, cool. Go for it.
Ah, this is good. I like this.
Okay, so meet Penelope Cruz, that's the black one, and Francisco Suave, that's the yellowy one, and these are my organisms that I worked with, and they're still living.
What are they?
That's a black molly, and that's it was called like a Sunny Mickey Mouse
Platy. It's a live bearing fish. I'm weird, sorry.
Yeah, so they live together in PetSmart, so that's why I adopted the both of them. Okay, why
Do
do
they still live
fish?
together? Sorry.
Yeah, they still live
In the
together.
same bowl?
Yeah.
Cool.
And you know, they really love each other too. Okay, I chose the fish because, as I was explaining earlier, it's very hard for me to touch a cricket, and that bugs scare me. And also, I was currently trying to kill a cockroach in my bathroom, and it was not going over well, so that's how I knew I couldn't choose. It was really bad. It was like 3 girls running around a bathroom. The fish I feel like are easy to work with. I've had fish ever since I was little, so it kind of made the project exciting. Outputs and inputs. I didn't try too hard to deal with other things before I found something that worked for me, because even I'm such an amateur, I just wanted to do the project right. So my input, which is right there, was a photoresistor, and my intentions were to recognize where the fish wet the surface of the water by observing the response of the photoresistor, because when the fish wet the surface of the water, the photoresistor would recognize that all the light wasn't shining towards it. And initially I wanted to use a proximity sensor, but I realized that that wouldn't have been able to detect the fish through the water. And the output that I used was a servo, which fed the fish. And by staying at the surface of the water for more than 15 seconds, although that part is not true, I revised that. The photoresistor will communicate to the servo to turn 90 degrees and release the Penelope and Francisco. What I decided on was, instead of 15 seconds, whenever the fish were at the surface of the water, the servo moved, releasing food, and then when they would go back down, the servo would go back up. So that's what I ended up having. It was more of a routine. These are some of my original design sketches. This is a video. Can I show my video?
Yeah.
Excuse me, the process. I was just showing, that was the code that I was working on, and I ended up totally revising my code. Because at first the servo was just moving on its own, not by me. It wasn't moving initially 90 degrees like I had wanted it to. And those are some of my original sketches. And that's my input, that's the photoresistor that I used. My output was a servo, which I used as a food distributor, and I taped a piece of plastic on the end of the servo so that it would release the food. An interesting story. During the making of this project, I attached my servo to the fishbowl, and when the photoresistor detected the light signaling to the servo to move enough food into the fishbowl, the fish became scared and moved to the bottom of the fishbowl for the rest of my trials, and they would not come back up. So they like swam down and stayed there, so I kept on having to use my hand to make sure that it worked. But they got trained. Difficulties. One difficulty I faced while creating this project was creating code for my servo. I could make the servo move, however, I could not figure out how to make the servo move, only when the photoresistor detected shaking. So at first the servo kept on moving on its own, and I had a hard time creating code that when the photoresistor detected light, that would signal to the servo to move. Then I had a hard time allowing the servo to move 90 degrees. So the code is definitely a difficulty that I faced. I believe said that the success was my project because I really did think that I would be able to create such an efficient tool. Not just on this project. I did not think I would be able to create an effective student capture. Here's another video. This is showing it in action. Because I couldn't bring my fish, obviously.
What draws the fish up to the
Whenever they feel like it.
Okay. So they normally go to the top?
Mm-hmm. I was figuring when they wanted food, they would usually swim up top.
Okay.
And that would, as you can see there at the bottom, so that's my hand detecting it. There was only one time when they actually detected, there was only one time when the photoresistor detected the fish, and that's when they swam to the bottom and stayed at the bottom. I think if I were to adapt to this, I would have somehow had more of a forceful light going through the fishbowl so that the photoresistor would detect the light parallel with the fish. But it seemed that the photoresistor had a hard time detecting the light through the water, through the surface of the water, through the plastic bowl. So that was a problem.
Wow.
An ecological interaction. I thought that this could be adapted for something bigger, such as an aquarium, where like a huge fish tank with sharks and stingrays and whatever, where there would be like huge servos which would detect through large photoresistors when the fish are hungry, and that's how they would be fed, something along those lines.
Cool.
And that would be the future for sure.
Awesome. Okay, let's, the next person, who's the next person who wants to present? Fight it out amongst yourselves. Rock, paper, scissors, right now. Go. Okay.
You guys can do it.
Okay. You're up. Set up your presentation, and we're going to go, and Alex, can you at least just show us your contraptions?
Sure.
And then we're going to discuss it a little bit.
Sure.
So first I would just like to say one thing. So the goal, this project was our stupid pet trick project. And so the goal was to get you guys to actually build something and learn very much firsthand all the weird difficulties that are going to come with trying to work with weird new technology that senses things and does things, and then also dealing with animals and getting them all to try to work together, even in like the slightest bit of interaction possible. So don't worry about if you think that your project failed. The only way that you can fail in this class is if you A, don't do anything, or B, don't learn anything. So the goal, you're all in class, you're not at some sort of weird industry job that's on tight deadlines to, we need this cricket tank by Monday or else our business is going to go bankrupt. Instead, you're all here to learn, and this class you're going to be learning a whole lot. So just make sure that you learn and just be honest with everything, and you guys will be fine. So yeah, if you can get us just showing things how to work, and then we'll ask Peter some opinions about
Sure.
things.
So here's my photoresistor. Here's my servo. And as you can see, there's a lot of light in this room, so that's definitely reflecting on this. Because in my apartment, where the light was right above it, it would move very accurately. But so you can see that when there's something that goes in front of the photoresistor, if light is blocked in some way, it's going to move the servo. And I had this placed properly on the fishbowl so that when it turned, it would dump the food. And when it was not affected, when the photoresistor was not affected by light, it would stay upright and not put food into the fishbowl. Whoa.
Ah.
Yeah, so it really does.
Oh, nice.
It really does.
So it moves as a function of light. So if there's more or less light is how much it actually moves.
Keep it
Keep it there, Eric, and have her keep it there, Eric, and then just have her put her hand in front of it.
It works.
Yeah, so she gets even more of a movement out of it.
I might.
It's like a mixtape.
That's what I was doing in my apartment.
That's super awesome.
So, yeah.
Wow, that's cool.
I thought it was pretty efficient, actually. And I was very surprised because I panicked to you like on Tuesday. So, yeah.
Did the fish actually trip it?
One time they swam up because they didn't know it was there, and it moved, and they swam really fast back down to the fishbowl and never ever came back up ever.
Oh, like it scared them.
Yeah, it totally scared them. So I just had to make sure it worked with the shade of my hand. But essentially, it's the same thing.
Wow, that's cool. So potentially they could be conditioned to this sort of stimulus.
Yeah, like
go to the light.
Yeah, and just swim upward, and then whenever they're, I don't know if fish can hear. Is that a stupid question?
Yeah, I think they can
But
hear.
I would say that sound waves move water around, and that would they would at least feel it.
And they could learn how to feed themselves.
Yeah, they can hear, and they also have these lateral lines on both sides of the fish that feel difference in pressure. So like if there's movement in the water, that movement translates through the water a lot better than it translates through air, right? So they feel the pressure, and then they can move accordingly. That's how actually schools of fish stay together, by using their lateral lines. They can feel the movement of the fish next to them and align themselves accordingly.
Cool. Okay, let's jump on to the next one.
Thank you.
Thank you, Alex.
Yeah, nice work. That was really cool.
Okay. That's all. I'm going to sit down this time. You're getting heavy, Peter.
Yeah, it's all that McDonald's.
Okay. Hey, I'm Katie, and I did my project with cricket, and I called it the cricket shaker. So I chose crickets, kind of like Alex, because they are less scarier than spiders and cockroaches, but they weigh more than ants, so that they can kind of trigger the sensors. Otherwise, I would have definitely chosen ants. Yeah. So crickets are cool if you don't touch them. And my inputs and outputs, like for my initial design, when we had to brainstorm like 3 different ideas, and one of mine was to like record the sound of the cricket chirping and then try to just like play that back and see what they would do. But we thought that might not be as like dynamic as we would like for a project. So then I decided to use like a rangefinder on the outside or on the inside of my bug box. And when the cricket walks in front of that, he triggers it to make the servo turn to the side of the box, so the box like breaks, aka shakes.
And so here are some of the drawings. And this one over here shows a cricket jumping kind of like across the center, the cricket center, and then the servos on the side. I was initially going to use 2, but instead I just chose 3 to rotate the box. And then this drawing just shows which wires I use to. And so for my inputs, I had a cricket and then I think, is it called a ping? Maybe that's just a
I think
brand.
Ping's the brand name
Okay,
of the.
so it's an ultrasonic rangefinder. So that it's down there and it detects when the cricket like walks in front of it. And then it causes the output, which is the servo. So this is a video of me trying to get the cricket to go onto the plastic. But he didn't really like the plastic and he couldn't really adhere himself to crawl up it because I think it's just really slippery. So he came up to the back of the servo and I was like, okay, come like get on the plastic. So it's kind of shaky and then my camera died after that. So, but you can see that the box does shake when he falls in front of the thing with my help by making him go. So, yes, like I alluded to earlier, I learned that crickets can only walk on certain surfaces, but they can walk on cardboard and paper. And so then this morning I put paper on the bottom of the whole box so that he could kind of, just like a little ramp that he could walk up on. Yeah, and then one time a cricket almost fell on me because the servo was activated and it was really scary. Okay, so success for me was no cricket involved right here. Being able to get the servo and the sensor to work together and just make the box turn, I thought that was really cool. And then I also have one second. I think my
YouTube's making puns.
That's me talking in the background. So because he has glued himself to that exact spot, he keeps triggering the sensor, which is great. Yeah, and I'm sure he loves it too.
It's interesting how he refuses to move. You think it would scare him more.
He's having a great time.
Yeah, he likes it. So
It's a cricket playground.
yeah, so that
Roller
is
coasters.
a success. The failure
Adrenaline junkie.
would be the type of wire we're using. I stuck it in the servo attachment and one of them broke off, and so then we had to, Andy helped me like cut the plastic around it so that I was able to stick more wire in it. So that kind of like tripped it a couple of times and I had to like use tape and other stuff, but it was okay. And then if I had to change like how I would do my design, I'd probably make it more like beneficial for the cricket. So maybe have like food drop in instead of like, because I like the sensor that he walks in front of it, but maybe not so violent for the cricket. So just food or water. Do they drink water or do they just do lettuce?
I don't
You get
know.
it from lettuce. And this is the lettuce.
Yeah, they get their water from
From the lettuce, okay. So just something a little bit more appealing for the cricket would be great. So, yeah.
Cool. Great. Can you go get it set up in the back or show us? And then the next person, Mary, do you want to pop up?
Okay.
Okay. Let's go look at this guy.
So, I don't know what side this side might be better.
So you have it kind of taped onto the table, hanging off there.
Yeah, and then the paper ramp so that it will go.
Is that the cricket in there? Oh!
Yeah, there's a couple cricket. I don't know. I can't see exactly what you can see right now. Hold on a second. Yeah, you hold that.
Oh, that is one cricket down
Is
there.
that the crickets that are moving it?
Yeah. So there's that little rangefinder in there, and
yeah.
every now and then they walk in front of it, and the thing freaks out, and you get crazy cricket jungle gym mayhem. It's pretty nuts.
That is
Sometimes it
awesome.
rotates.
It's like a theme park for cricket.
Oh,
Ew.
okay, so
Sometimes it like, I had trouble, my most difficult thing was, but using the inches between like here to there, because I had it set to 4 in my code, which is what it's set to now, so that if it triggers it with 4 inches, but then that sometimes like makes it rotate by itself, but then when it's less than 4 inches, it doesn't trigger. So kind of like the accuracy, I don't know if you buy a more expensive sensor, then it would pick it up better, but that was the biggest thing that I had trouble with.
In my testing of it as well, with the rangefinder, it seems that no matter where the cricket is, it only decreases the average by 1. So it's only like a little disturbance signal.
Like when I was able to use it with my hand, that worked really well. But I think it's just like more finicky maybe because there's something right here.
and also the crickets are smaller. These things use big sound waves that blast against it, and these crickets are kind of shaped like stealth fighters. So the sound waves might be bouncing around
Yeah.
all over the place, not coming back smoothly like they would from your hand.
So, yes, I think it could be changed to be more accurate, but it's still cool, I guess.
Peter, you have anything?
The cricket's behavior is changed by the servo at all? Or they pretty much do what they do?
Well, initially, like this whole time I've only had 1 cricket in it, but I added more this morning. But 1 cricket, it was difficult just in general to get him to walk on it. Because I would try to tap it and stuff, and he just mainly hung out in the corners or behind here, like they're interested in the black tape, I guess. So getting him to actually go across was hard, and he only did that like once. So I've added more in there, and I think they're really hungry, so they're really mad right now. But yeah, it's maybe if I limited the space, that would be better. But then it would be going on the whole time. So I tried doing that, like sticking a note card in the side to like block off some of the space, but that didn't really help either. So,
I'm just thinking about how if the cricket likes it, it might somehow figure out a way to trip it more often. Whereas if the cricket, if that's really bothersome to the cricket, it might be like sort of a negative feedback loop, like trying to avoid movement or something.
I think that's what happened, because he can crawl under the paper and under and around, kind of like this part, and he did that a lot, and I feel like he was hiding from me because he didn't come out much, and I didn't really have a way to get to him. So I would say definitely a negative feedback loop. That's why I'd like to change the project to make it less annoying for the cricket.
Yeah, well, you might be able to test the cricket personality, see which ones are adrenaline junkies and which ones are...
Yeah, that would be cool.
Everything?
Yeah.
Everything.
So, quick recap.
Sure.
Peter was mentioning, was talking about how, like Alex's project, possibly the project itself may change the behavior of the things in it over kind of a longer period of time. Other things that came up were the sensors. As many of you probably know by now, lots of the sensors that you're going to use aren't going to function ideally. Ideally, the proximity sensor says there's something in front of me at this exact range. But often that's not the case, and sometimes you have to do your own interpretations of their outputs. Like Eric was talking about, his proximity sensor wasn't really telling him how far away the crickets were, but he was able to notice that it's always at least a little different. So you can use these and kind of make your own sensor of just crickets here or not from these less than ideal sensors. Cool.
Okay.
Awesome.
Alright, so it's Project 2 Stupid Pet Trick by me. Yep. Okay, next slide. Oh, never mind. Okay, so what organism did I use? I used Victoria the Ocellaris clownfish, and to the left you have a picture of Victoria in her actual tank with live rock and stuff, and the pictures on the right are her in a little 2.5 gallon I used for the project.
Yeah. Okay, why? Well, I originally wanted to use a Mandarin Dragonette because the point would be to find a way to get them to feed in captivity. But I decided that I didn't want to do that because tank bred ones are really expensive, like $50 to $60, and the wild caught ones are scraped off of reefs, which is bad. So I didn't want to get one and kill it unless I have like a big enough tank to keep it alive without my project working. So I picked a clownfish because they have similar coloration as the red Mandarin goby, and they live in the same habitat, and they're really hard to kill, and they're kind of brave. And eventually, if I can figure this out, I'm going to put the Mandarin in the same tank as Victoria. Anyway, so these are the inputs and outputs I tried. I just had a field day one afternoon and played with all of them.
Nice.
So first of all, I tried a servo, just using a servo to stir the water, because that was really, would be a lot easier than playing with a relay, but it didn't seem to do very well. Like, I tried messing with the power settings, but it would just kind of waved. It didn't really create a current. And I tried a 400 Marineland motor, which worked for a while, and I don't know why, but it died. I tried a Scribbler too, if you can see in that one picture, is that red robot, which it has a couple of sensors that come with it and a motor inside that I was going to play with, but it required Bluetooth and things like that, and I didn't want to cut it open, so I decided not to use that. And also, like you see up there, I tried using a motion sensor, a PIR sensor, which I found out pretty quickly doesn't work on water and glass. Okay, so there we go. What?
Quick recap, she's working with awesome, crazy fish. She tested out a bunch of lots of different sensors with her fish.
Okay.
Anything else? Or just keep going.
Keep going?
Yeah.
Okay. So I have a bunch of design sketches. So I originally had the one, and I was going to use Jack, which is a Jack Dempsey cichlid, which is very different. And I changed that. And then this is me figuring out how I could switch power from the Arduino to a wall outlet power before I knew that relay shields existed. And that's me. And this is near the end, my end design sketch, which has like pseudocode with it too. I don't know why I used winning as my boolean. It just felt successful when it started working. Okay, so my input I ended up using in the end, which worked a lot better than I thought it would, was the webcam on this computer. So what I would do is I would run the webcam, and it would send an image of what my webcam picked up, and then I would use processing to iterate through every pixel in the image. And then I use, in my code, I use color detection to pull out RGB, R values specifically, higher than a threshold, because there isn't a lot of red in everyday stuff. So I didn't really need the G or the B values to detect things. And the desired goal was to detect when the fish was in a specific area of the tank, which would indicate that she's moving around and not just hosting in her little anemone, which wasn't in there because I don't want to touch it.
What was the fish you ended up going with again?
Clownfish.
Cool.
Yeah. And so my output, which explains this a little better, is part of the problem with getting Mandarin gobies to eat in captivity is that they aren't stimulated by dead food to eat it. So I was trying to find ways to make the mysis shrimp or cyclopedes or whatever you feed it appear alive. So I wanted to create a current in the tank to make the food dance around. So the output I ended up using, which is a slightly more powerful pump, which all it does is spin, which I used it, processing would turn on the Arduino Uno, which would run code that would switch the relay shield, which the motor was plugged into, and so the motor would turn on. Okay, so one thing, interesting thing that happened was that my relay shield spark, and I'm sorry, that's like gonna be the most outstanding thing from this project for me forever. Because I did have a mild panic attack because this like electricity went into the air, and it blew out my power for a while. And I learned things. Is don't. I'm going to use a lot of electrician's tape if I ever cut wire again, and because I'm pretty sure two of them touched when I pushed it a little bit. Okay, problem I encountered was getting the color detection thing to work when I was looking at images in the real world. Because, for example, especially with my tank, this was a problem because there were incandescent lights in my room, so the tank would reflect those lights and it would pick up right off of that. So basically, like this color spectrum, it would say all of that is red. There's always red just when it was looking at an empty tank. So I did that by turning off all my incandescent lights, adding more stuff to my color threshold, and I also cut up a big sturdy poster board and made like a little box to work in. Okay, my success was that seeing less red, once I fixed those problems, it actually worked much better than I thought it would with my basic built-in webcam. And I have a video of that just happening, which is, I'm going to skip me talking about how the code works.
Cool. That's good documentation, though. Talking through the code.
That's me turning on the webcam and then holding up a piece of orange plastic, and then so the webcam's on, and I just hold it in front of the webcam, and the light's really obvious to test.
Nice.
So it sees orange, yay.
Awesome.
So that actually worked a lot better than I thought it would. And also, I'm excited that this works because now that my processing can talk to my Arduino, I can use all of do really cool stuff with my Arduino. Okay, so my ecological interaction, I actually kind of started with the concept, which is to eventually create a machine that would help train a Mandarin dragonet to eat in captivity so that people would stop killing them. And I would have to change my design a lot by including a method of feeding, which I actually was going to do before my relay exploded, but that's okay. Getting a camera that doesn't put in random colored pixels every now and then, because that happens. Having like a physical indicator to the fish that this area is good, because I'm sure given enough time, they would, with my experience with owning these fish, they would learn that this area means food and start going over there and then kill themselves by feeding themselves too much. And I wanted to have a current that's more than just like on, and I also wanted, another thing I was going to do before my relay blew up is improve my color detection so that it would only detect movement patterns instead of just there is orange. It needs to say there is orange and it's moving, but that would happen all on the code side. And then I show a video of it where I'm actually not talking. So that's poor Victoria.
Cool.
Oh, it's sideways.
Okay. We can turn Peter sideways.
How do I fix the sideways?
We just turn our head.
Yeah, we just tilt our head.
Okay, I don't know if you can see it. You can definitely hear it.
Can somebody flip the lights in the back real quick?
Andy, I think you're flipping him upside down.
Yeah, that's,
I'm flipping Peter upside down?
yeah.
Oh, well, there we go. Okay, there's the bottom.
Oh,
Okay. Can you show us? Okay, so there's the clownfish in the tank.
It's sideways. We're gonna refine. So you can hear it a lot better than you can see it in the video. In real life, you can see it pretty well. But
So there's a pump.
and she went
Oh,
in the
okay.
pump and it turned on, and I guess there's some algae in there floating around.
That's cool.
Awesome.
So there's like a delay on it, so that's why it's kind of random. But if you see the code output, so like when it goes, God, I can't point at my screen and you guys see it. But basically, when she goes in front of the pump, because that's the only area of the tank she can see, or the camera can see, it goes on. And
She seems kind of fascinated by it.
yeah, clownfish are great because they're kind of hard. Like, she's not very smart. She was really easy to get out of her main tank, and they just do their thing. You could be like setting off bombs, And at least that's my experience with this one.
Cool.
And it's kind of funny that I used a clownfish. This is kind of a joke because of Finding Nemo, they're like the #1 fish that gets killed in saltwater tanks. And mandarins are also very high. So they have like things in common besides the color.
I kind of like how you have this goal with your project of trying to help people not murder their own fish.
Yeah,
That's cool.
murder these cool looking fish. that-
Cool. Next person, who's the next person? Eric. Cool. Question from Eric.
I don't have any questions.
Okay. Arm raising for Larry.
Yes.
Are you gonna say something?
No, I was just going to go after Eric.
Oh, okay, sure. Okay, Larry's up after Eric.
Fighting fruit.
Awesome. Peter.
Okay. well,
Questions?
long effort here first.
I sorry, couldn't exactly hear what was the output. So I saw it was a webcam picking up red pixels, and then what happened when that?
It would turn on a relay, which turned on a surge protector, which turned on a pump that created a current in the tank so that stuff floating in it would move around.
She had a really powerful water pump.
I see.
How do I look?
Cool.
And her goal was to be able to, she would feed the things, and then they would seem like the food is coming alive because
So,
it's being blown around.
Like if
by
I could
the
feed
pump.
it dead mysis shrimp instead of
I
live
see.
mysis shrimp, that would be a good improvement. Thank you.
Oh, cool.
I'd run out of live mysis shrimp in a day.
Awesome. You did a really good job, really like thrashing through a whole lot of different technologies and troubleshooting some very tricky situations.
Yeah.
Good job with that.
Oh my god.
Pop on to
More
Eric. Nice.
So my stupid pet trick is a bug buggy,
Got it.
which is essentially just a motorized RC vehicle powered by an Arduino that uses sensors to detect when a cricket is moving in front of the sensor and the vehicle moves forward. So this is one of my crickets that I observed for a little while. There's actually a bug on the screen. And so, as you probably can tell, my animal, or my biotic organism, is a cricket. I've had them for about a week now and have been observing them every day and found out some really interesting things about them. But originally, why did I choose crickets? They were capable of moving quickly. That was my #1 thing. I wanted something that could move back and forth around the box rather quickly. But also, they were large enough to be detected by the sensors, but also small enough to fit inside the box that I was going to put in on top of the vehicle. I also wanted things that were well known and readily available, so I wasn't experimenting with some unknown spider or something. And they're very easy to take care of. So I had quite a few attempted inputs and outputs to detect where the cricket was in the box. I tried pressure sensors, motion detectors, IR LEDs, and ultrasonic sensors. And for my outputs, I looked at the Rover 5 platform, which is from SparkFun, and also some servo motors to kind of move the box around. But in the end, decided to use the ultrasonic sensor and some form of the Rover 5 platform. So I went to the drawing board, kind of sketched out what a cricket looks like, tried to understand more about their body, and also how I was going to implement this rover platform. So my final product sketch kind of shows the cricket in the box. There's sensors to detect where the cricket is, and it zooms forward whenever they're detected. I soon realized that the Rover 5 platform was not what I wanted to use. But my input in this case was still the ultrasonic sensor. I realized it was able to detect distances and could easily detect disturbances, even though they weren't that great, when a cricket walked by. My output in the end was a converted RC vehicle. I realized that this would be much easier than working with motor shields and having to put a kit together than just already using something that was made. So the wires come out of basically essentially the motor shield inside, which runs it off the RC controller into the Arduino. So an interesting thing that happened while I was doing this project, so I finally got the thing working, as you can see in the picture down there, and then decided to give it a good old test on Freshman Hill, and it didn't turn out so well. The vehicle actually launched off the sidewalk, the bucket fell off, came back, hit the curb, and then I had to pick it up while it was still rolling around. So ended up knocking the bucket off and kind of removing some of the wires. So I had to come back in the next day and kind of put it all back together. Also fixed most of those problems in the code by kind of just making it go on and then off, instead of just full speed. Because it's a pretty fast RC car. And it even has a turbo setting, and that's not even turned on. So I can't imagine what it's like with that. Some of the difficulties in observing the crickets, they don't move when they don't want to. So sometimes they will just sit up on their thing and they will just chill out and do what they want. And also it's really hard to get them in front of the sensor unless they are really active at the time. Also with the motorized vehicle, it was a little bit of a difficulty to get it converted over to Arduino and get it to work with the sensors. But in the end, I think it was a successful implementation. So, talking about successes, these videos don't exactly line up, but for the most part it shows you at the top, showing the code, and down on the bottom you see the crickets, and when they move in front of the sensor it moves forward.
Awesome.
So ecological interactions, maybe some changes for the future, a box with a more natural environment or habitat for the crickets. Right now it's pretty much just an empty plastic box with this weird sensor in the corner that they don't really know what to do with. There's some duct tape in there that they get caught in. It's not exactly a natural habitat. Also using incentives such as food to get them to go to certain sensors that I wanted. Also testing the bug buggy on different terrains such as outside or maybe even just places they've never been before. Maybe taking a bug buggy through the desert. And also temperature changes inside the box and see how that changes their movement and how they're picked up. And so that would really be the temperature of the environment, not necessarily controlling the temperature inside the box.
Cool. Great. Can you run around again? We'll chat and then Larry set up. While he's setting it up, Peter, do you have any questions, remarks, suggestions?
So the bug buggy itself has its own battery. I think he's talking with Aaron.
Oh, are you talking, Peter? You're either faking us out or your microphone's off.
How about now?
Okay, now you sound good. What were you going to say, Peter?
I'm listening.
Okay.
Okay. So the bug buggy itself is powered off its own battery on the bottom, but the Arduino is powered by a 9-volt. And so putting the 9-volt in. They're all over on that side right now. And it's still moving. What I realized is basically every time you move the box, you actually have to hook it back up and kind of recode it based on what's
you have to recalibrate it every time you
between
move.
12 and 13 and 11.
Uh-huh.
So right now it's probably not perfectly calibrated.
Often in a lot of projects, like even in the kind of ant sensor that me and Peter worked on a little bit over the summer, you'll want to put in a little bit of calibration code at the beginning. So like in the setup part where you just collect a couple of the readings and get a baseline because it may have shifted slightly.
Yeah.
Wow. So what's the calibration here? It's the speed calibration or what?
It's the he's got a little proximity sensor that kind of jostles around every time he moves the box.
I see.
Kind of the thing with the white on top of it. And so if it gets uncalibrated, it'll move more on its own, and it won't be as sensitive to the crickets coming around. But now it looks like it's going okay.
Ah, cool.
Great.
So originally he had it just going full speed. Is that what I saw?
Yes.
Yeah.
Luckily there were no crickets in at the time.
Oh, that's good.
I
Good.
just put my keys in there.
Mm-hmm.
And
Nice.
Speed delivery, auto delivery for crickets to feed people who have frogs and lizards and stuff.
It could be any kind of small animal mobile.
Yeah. Yeah.
Deliver themselves to their doom.
Clips.
Be a lemming mobile. All right, cool.
That's pretty cool.
Drive it off the cliff.
Yeah, you could train lemmings to not be suicidal. Counseling. All right, cool. Larry, show us what you got.
Okay. I kind of feel like my PowerPoint's a bit underwhelming here. Hi, I'm Larry. This is my stupid pet trick presentation. My stupid pet trick was making stupid pets smart. So I wanted to teach little furry, four-legged things that know how to calculate like complex concepts and teach them the concept of numbers. So let's move on. I really don't think this is enough. My animal was a dog. Dogs are very susceptible to new commands, easier to train than most animals, friendly, man's best friend, aren't as wary of strangers, but mostly because Mary has a dog and she brings her to class every day. So it was more of a proximity thing. Although I do like dogs. I'm not really a big fan of bugs, so the less I can touch bugs, the happier I am every day.
That's not how Peter feels.
Yes. My attempted inputs and outputs. Originally I was going to kind of make a find the ball cup swap kind of thing, where you'd have 3 sensors, 3 lights, and it would switch the lights between the sensors, and you choose which cup the ball was under, like a switching game. But that tended to be too smart for a stupid pet trick, so I decided to make stupid pet smart. It kind of runs in a loop of output, input, output. First, you turn it on, and it gives the animal a signal that it's turned on. Then it gives the animal how many things to count to. The animal then is allowed to push the pressure pad, and as it pushes the pad, a light turns on to show that it actually is counting, and it gives a visual feedback that the pet can process. And once it hits the correct amount of numbers, it starts sounding off again, telling the pet that, yes, this is great, you've counted that far, and then it just loops, and it gives it a new random number, and just continues like that until you turn it off. My original sketch, I didn't actually do too much sketching. This is my original sketch of the original idea I had. It's a bit dark since it's just a picture of my journal, but you can kind of see it. This is the idea of it. If you ever seen those carnival games where they have one thing under a cup and you just switch around the cups until you find it. It was going to have a buzzer on the side, 3 pressure sensors, and 3 LEDs, which would be able to switch to each other. I eventually changed from this, like I said. I do not have an original sketch of that, since it was essentially the same thing, just dumbed down. So my inputs, the only input I really have is your general SparkFun square 1-inch pressure sensor, or pressure resistor sensor, I think it's called. It just takes in inputs at opportune times. Depending when you press the pad, it does different things. It either starts or counts. My outputs, there's 2 things. There's a standard Radio Shack alarm, like a little buzzer, it's about half an inch, and a LED light, a green one, standard size. The buzzer sends out different signals depending on whether you're starting or counting, and the light signifies that you touch the pad, pretty much a visual marker for your animal, so they know, I need to push this and make the green thing happen 4 times, or until it starts beeping again. Happenings, interesting things that happened, nothing. Nothing interesting happened.
Nothing interesting happened the entire time.
The entire time. Actually, I have figured out, it kind of crosses over with failures, difficulties. Maddie doesn't leave Mary. So I recommend actually trying this with a pet that's very familiar with you or would actually accept training from you. Another thing is Mary's server exploded, so she had to fix that, and I didn't have as much time with her. Things happen. Successes. I actually managed to program this thing. I was having a very hard time figuring out how to take in real-time input from a pressure sensor, and if you look at my code, it's a giant spaghetti mess of ifs and else ifs and elses and else ifs within elses and whiles, and it's really nasty. But I actually managed to get it to run in a loop that takes in real-time input from a pressure sensor. Normally when you use a while loop or something like that, it instantly freezes all input coming in, and then it just takes that input that's frozen and runs it through all your ifs and else's. So if you tap it once, all of a sudden you've got everything is go, and it runs through the whole thing all at once. So I managed to get that right. I'm very proud of that. Ecological interaction. I'd imagine this, even as an environmental thing, it would be more useful in a sterile environment than a natural environment. I think it would be more useful if there was more weight placed upon counting, maybe food or something like that. Some obvious reward for knowing how many times you have to make the green light turn on. Because right now all it does is give you a buzzer, and it depends on the owner to give out some form of reward or treat or good job for learning how to count, because otherwise this is of no use to you at all.
Mm-hmm.
Counting really isn't something necessary for animals, so it's more of a human need.
It doesn't care if you give it a bad grade.
Yeah.
Cool. Well, let's see what you got.
I'm going to attempt to make Maddie push the pad, but
Cool.
it does work, at least.
Then we just have Danielle left, right?
Yeah.
Yeah, me too.
Oh,
Should we go first?
No,
Yeah.
mine's super
it's
over.
107.
You should reward her
20
by
minutes?
giving her
Okay.
a leather shoe.
A leather shoe? I don't have any leather shoes, Mary. I can do that, though.
Okay. Peter's got to leave in 7 minutes. We're gonna have you last three just show your devices real quick to him, and then we'll have you do your presentations afterwards. Or we don't have to worry about
All
that.
that's left is mine.
Okay, that's all that's left.
That's all
is
that's
hers.
left of mine. It exploded.
What happened?
My sister accidentally stepped on it, and I tried to rewire the relay. When I did that, I accidentally switched two of the wires, and it exploded. Like, literally, there was fire. And
Fire?
there was fire. And my computer won't turn on now.
Was
So,
this a malicious act by your sister?
yeah, she hates bugs, so she did to me on purpose. Actually, it happened to Mary, too, but on a lesser scale. I mean, her power went out, but the microphone survived. I think it's because it wasn't... I think it's because this was like the input. My brother said that the relays are designed to only break on
What's
one
that?
end.
What was the original function of this device?
I'll have her tell you.
Yeah.
Or yeah, tell it right now while he's still
So I was, obviously crickets, they chirp faster the hotter it is. And there's like a very specific formula for that. You take the number of times they chirp in 14 seconds and add 40 to it, and that is the temperature in degrees. So I decided that I was going to, I had an amplifier for this too. This is a preamp. So it's the microphone and then the preamp. And I had this hooked up to an amplifier, so it was like really sensitive to noise change. And I had that hooked up to a lamp. And I had these relays for this lamp to use a battery to switch it off and on. So that's actually why it exploded, because I was using a relay. Don't do that. And when the crickets were chirping slow, it would turn the heat lamp on. And then once the crickets started chirping faster, I think it was like got 5 degrees hotter in the cage, it would turn the heat lamp off. And then,
that's pretty cool.
yeah, and once they started chirping slower again, it turned it back on. And the biggest problem I ran into was that sometimes they would chirp kind of slower. I don't know why they would chirp slower. I think because they were kind of afraid. So my code actually got 100 values from the microphone, averaged them together, and put that as like the baseline. And whenever there was a slight deviation from that average, I think it was like 60 points or whatever from the resistor, it would turn the lamp on. So that way, instead of having to have a certain speed of chirping, it would just have the average speed of chirping. I didn't come with that idea myself. I found it online. I thought it was amazing, so I just stole it. I was like, I'm taking this, I'm using it. And it actually worked out really well. So that's what that was supposed to do. It was really cool, and then it exploded.
You got a video of it, right?
I was going to keep
But did it work?
It did work,
Cool.
actually. It worked
That's
really...
pretty amazing.
It worked really well. I was surprised it actually worked as well as it did. But it worked, and then it died. I was going to keep it. I was going to make a clapper lamp. We're going to have it like hanging in my foot.
Awesome.
It's dead.
Oh.
Okay, Larry, let's see your thing.
Should I use Maddie or should I just do this?
No, you should use an animal.
Okay, cool.
This is not
Let's do this.
Larry computer interaction. This is animal computer
I'm
Alright.
interaction.
going to help
So-
you. Oh, you got to
Thank you,
get her
Maddie.
attention.
Maddie, over here. So let's turn this on. It might be a bit, you probably won't actually be able to hear the alarm.
Oh,
Turn it
no,
on.
you might want her to be up there with it.
Yeah, no, it's not working.
Okay, we got a light.
That's not supposed to happen.
Okay.
And I'm still trying to actually get this whole thing working. There we go. Maddie?
Maddie
Maddie?
wants to talk to you now.
Okay, I'm going to steal your paw, girl. Alright.
I'm
Hold on,
gonna
hold on.
lick you.
Okay, I can hear the buzzer beeping a little bit.
Okay.
Alright.
So it just gave how many times it's supposed to count. And I
Okay.
need Maddie over here. Maddie.
So let's see if her paw can even trigger it.
Maddie. Come
Maddie.
on, girl.
He's
Maddie.
like, I'm gonna be bashful.
Come on, up here.
Shake.
Now that you want something
No,
from me,
no.
I'm gonna hide.
Okay.
Okay, just pick her up, Larry.
Okay. Maddie.
Or have Mary pick her up.
Okay, there we go.
Okay.
Okay.
What do you want?
I need her paw on this
where
pad.
do I put the
Pad.
dog?
Right here. There's one.
Ah!
Yay.
That actually seems like it works pretty good for just a dog paw like that.
2.
She's like, what's
Three,
going on?
4.
So-
Yay! And now it says that you've done well, young
Okay.
Padawan.
Good
And
job.
now it's telling you to count more.
Cool. Alright, then very quickly, Danielle, can we just show you your thing right before Peter has to skedaddle?
Cool. So flowers, white flowers, certain ones, they can change the color if they're dipped into like different colored waters. So we're going to color code ranges of temperature. So 80 degrees Fahrenheit or higher, like this machine will sense temperature and then dip the flower into that like color code. So say it's some temperature, this will bring up the flower and then sense what temperature it is, bring it to the appropriate cup. It's a little warmer today, so it's going to go in there. My test code just brings it down like temporarily, but ideally it's supposed to dip it in there for like 12 hours or so for the flowers to change color. So since I only have text code, I have presents for everybody of the different colored flowers.
Yay.
Cool.
Oh, cool. Oh, wow.
Yeah.
So it actually works. Nice.
Yeah.
There's the blue one, there's the yellow one.
Yeah. So
That's
I don't know.
cool.
I don't know if you can you see that at all, Peter? These are kind of
No.
bluer. These are yellower. This is red back here.
Ooh, where? Ooh.
And that's dependent on the temperature.
Yeah. Well,
Oh, that's pretty cool.
it will dip
Oh, yeah,
it
you
into
can
the
see the
color depending on the temperature. But the flower sucks it up all the same, 12 hours from now.
Yeah. So her input is, you can see she has a little temperature sensor on the base of the flower, right around here, that's kind of attached on there with a little piece of tubing. And that's taking in temperature input, and then it triggers based on some sort of time schedule, dipping the flower into one of these things. And at the end, you get kind of like a temperature chart of the past couple hours or days or whatever,
Yeah.
outputted through the flowers themselves.
Oh, that's pretty cool.
Totally.
Temperature logger, flower style.
Yeah.
Water ladder.
Awesome. Cool.
Wow.
Well, we can let you go,
Maddie.
Peter. Thank
Maddie,
you
come here.
so much for coming.
Thank you, Danielle.
This
Yeah.
was really awesome.
My pleasure.
Thank you.
A lot of really amazing stuff.
Are you
I'm really impressed. You guys are awesome.
We'll invite you back for the very last in December. We'll have their third and final project coming up.
Yeah.
We'll invite you back. If you
No.
want. Cool.
It's not fair.
Okay.
Yeah. All right.
Thank you.
Bye.
Bye. See you again.
Yay.
Oh,
Cool. Yeah.
You want one?
He's a great guy. I totally do.
We have 10 minutes.
What's that?
10 minutes.
10 minutes. All right, that's cool. We can do two presentations.
The fastest
You can have my file if you want
you
it.
will ever see.
Really quick, I'm going to tell you guys your homework for the weekend. So you've all been really stressed, and so I'm going to try to give you guys easy homework this weekend. So for the entire weekend, until next Tuesday, I want you to read 2.5 of these Ishii readings. They're pretty simple, big pictures. They look colorful, fun. And then you have to send me your presentation, get them to me somehow, email, Dropbox, whatever. But your main Bioperformance 4 is going to be due on Tuesday. What's Bioperformance 4? It's going to be Rapid Biological Survey. Your goal is we're going to have a contest. Who can turn in the most pictures of the most different animals?
so that's what we're doing? Just
That's
take
it.
pictures of
All
them,
right,
so-
Pictures of animals. Pokemon Snap. You're just going to go around
Wait,
hunting
wait.
creatures.
Wait, let's just
So,
and
okay.
use my fish tank.
What about all those pictures of bees and spiders I submitted for the last bioproject?
No, it has to be new. It has to be taken over this period. Every picture should only include one animal, or you're only going to get 1 credit per picture. So if you have a picture and there's like a squirrel and a person and bacteria, we're not counting that. Okay? 1 picture per, and we're going with animals, kingdom Animalia. Okay?
Do humans fall into that category?
Humans fall in that category, but you can only get 1 picture of a human.
Okay, I have 2 animals.
Oh man, she's already on the ball. Okay, let's get these last 2 presentations going. You guys are terrific.
Wait, is that,
Oh,
that's due
also-
on Tuesday?
Let's do on Tuesday. Not right now.
Oh, okay.
Andy.
That'd be good.
Tuesday.
Start now.
Andy.
Sure.
Let me get you back all your stuff. This is your pressure pad and all of these alligator clamps. They're yours.
Okay. Load them into my box back there, my big cardboard box.
Oh, sorry, Annie. I'm sorry, I told you to sit behind them.
All right, let's watch Danielle's presentation real quick, guys.
Go, go, go.
I'm so fast.
Boom! Super fast.
Oh, okay.
We're excited.
So everybody knows what this is the introduction slide. What was the organism? Everywhere on the internet recommends white carnations. White daisies are for the testing period, but they also work as proven.
So is this a carnation or a daisy?
That's a daisy.
Okay, cool.
Why did I do this? It started as an idea to make it like at the end of 7 days, if you did this for 7 days, you would know, oh, the last week was actually pretty warm, so you could have like, and it would look like in the presentation, you could like have a bunch of yellow flowers if it's warm, a bunch of blue flowers if it's warm. But it kind of grew, especially with the whole like the sensor is actually on the flower. The flower kind of expresses itself with this. Oh, I called it a flow vase or a flower weather vase. So that's, if I say flow vase, that's what I mean. Attempted outputs and inputs. I interpreted this slide as other ideas I had. I wanted to work with mushrooms, composting, or cat shelters, but yeah. These are my original sketches. I was thinking of only 2 colors at one point, but just this idea of like, oh, I have to think about many different actions. Rotating is one action, up and down is another action. Maybe I could use beakers and beaker stands, but you know, when you rotate, you need something circular. So I found a need to just make a bunch of these things too. The inputs and sensors, for the input, I used the TMP36, and I found a way to kind of wire it up and tube it right onto the actual flower. So it senses the input. The actual actor is this kind of like, is the flow base itself where it actually moves and then places it into the appropriate glass. One interesting thing, I think generally the fact that flowers can absorb color is interesting. And it's the process of transpiration, you know what that was. I guess something that's more interesting is that there's more ways to experiment with the amount of food coloring and the amount of water. As you can see, like yellow and blues and greens popped up really well where red didn't, and I think I would just need more time to understand how much food coloring and how much water is needed. Difficulty, it would have been better if I used 2 standard servos, but I ended up having only 1 continuous servo for one of them, which is horrible. That's for a different discussion. But
This is important. There's 2 types of servos that exist out there. There's servos that are really dumb called continuous rotation servos. All you do is send them a number and they just start spinning one way or the other. Whereas most servos, you send them a degree and they move exactly to that degree. Those are the servos you want them for different applications, but they look the same. So watch out.
calibrating continuous rotation servos is also really horrible. The success, generally laser cutting, I did not kill myself, so that was a success. I got to really just do that. Also, for anybody who cares, the bottom part is made out of 1/2 thick like wood, and it's just better to use a bandsaw for that than to try to laser cut it. So anything greater than 1/4 inch, I think it's better to just use a bandsaw, just for future. Ecological interaction. So if I said that the product of this is to make flowers more visually expressive. By like inherently, flowers are already visually expressive. So like, what does the flow base offer? It offers like a day-by-day kind of visual expression, but that's kind of only for the humans. Like flowers don't care if they're like yellow or green. Like if they weren't born that way, then they don't really care. So I guess in terms of like a whole like ecological interaction, what if we could start making like, so like where other things are visually expressive would be like poisonous frogs that kind of have like neon colors to say that they're poisonous. So what
It's referred to as aposematic coloration, showing things that you're dangerous.
So what if we can make flowers aposematic and then poisonous flowers and poisonous coloring so that suddenly the whole environment would have to learn this is super poisonous.
Cool.
Don't eat it based off of its color.
Awesome. There'll be flowers growing out in the wild just surrounded by dead creatures that have not learned the lessons. All right, cool. Anna, you got it.
Good job, David. Thanks.
Any questions for Danielle?
Hey, if anybody wants liquids to hydrate themselves with,
You know, I'll take one.
What?
yeah.
Are those like up for grabbles?
Oh,
Yeah.
yeah. Which one do you
I
want?
want blue.
You
No, I wanted the blue.
The lemonade's not even open. I am not.
Alright, Larry, you have to push your
Yellow?
want things in life.
I could, but I have to do these first.
Mellow yellow
The
was
last time I
actually
had this, that was in the Empire State Building.
Hey, look at that.
It used to be yellow.
What is it, like vertigo? And I got sick, so I don't.
You're next vertigo too.
It had like.
Boom. Guys, everybody, presentation.
Why did Larry sniff stupid stuff?
Oh, I'm sorry you did my stupid presentation.
There it is. Okay. Alright.
Play it from beginning. Or current slide. You can't lose.
Okay. So this is my signature trick. The basic goal of the interaction was to regulate temperature using cricket sounds. Originally I thought maybe I could repeat the sound back to them, but then I was like, that's kind of pointless. Because I mean, I don't know for sure, but I'm pretty sure crickets don't like repeat sounds to each other. They probably like that temperature. I thought was a more interesting and applicable one. And also I realized that if I were to repeat a sound back, it would probably just like loop and start playing that sound because the microphone would pick it up and play it back and it'd keep doing that. So I used an electric microphone and a preamp and a relay to turn on a heat lamp. And if the environment is kind of quieter, if the crickets are chirping slower, then the heat lamp will turn on. So when I first turn on my gadget, the heat lamp will automatically turn on. That's just what I told it to do. And then the crickets will start chirping faster. They don't chirp much faster, but they do. And I made sure the numbers that I used were very, very small for like differences. So sometimes the heat lamp would turn on when it wasn't supposed to, sometimes it would turn off, but it worked for the most part. And when the chirping started getting faster, they'd stop chirping. My basic sketches, okay. So if this is me just trying to figure out how the heck the relay board worked. I didn't know like anything about it. I knew they were dangerous, so I didn't want to explode anything. And today, I was successful. And then last night I was like, oh, I got this. And I was like really confident, and I just kind of, and then no, it just exploded. So this is my final thing. You have to make sure that the COM peg goes to the electrical source, and the either normally open or normally closed peg goes to the light bulb that you want to light up, and then the coil pegs both go to your battery. For some reason it took me forever to figure out how to get the battery work, and then I just tried it, and I was like, oh, okay, it works. And then that was the electric microphone I would have preferred to use, but I couldn't find it. I actually had to drive 30 minutes away to go find a microphone from Radio Shack, because my here didn't have one.
Didn't we have one of those?
No, it was a CO2 sensor. I thought it was a microphone.
I had a little microphone around here somewhere.
Oh,
Anyway.
okay. Well, that's awkward. So here's my
electret microphone, all hooked up to the amplifier, the lone survivor of this project, right here. I should have a no, I have a video of me playing with my relay. I actually had to put this together. Thankfully, it had like step-by-step instructions on how to put the preamp together, or else I wouldn't totally failed. So I used the Arduino, obviously, the breadboard. The breadboard did survive the explosion. That's
Nice.
good. Obviously, 'cause it's just wires, so it's fine. The Arduino